Today I'll be presenting about Chapter 9.1, the activities of the Sun that affects the Earth, from our science syllabus in Form 3. In general, the Sun is a massive ball of hot glowing plasma that plays a crucial role in space weather, which refers to the environmental conditions in space that can affect Earth and other celestial bodies. Now, the structure of the Sun is made up of two main layers, which are the inner layers and the Sun's atmospheric layers. The corona, chromosphere, and photosphere are the three layers that form the Sun's atmosphere. And the rest are the convection zone, radiation zone, and the core. Besides the Sun being the source of light and heat, there are other phenomena that affect the lives on Earth, which are granules, sunspots, solar cycle, solar flares, solar wind, solar prominence, and the coronal mass ejections. Granules are lumps of gases that are formed on the surface of the Sun due to high temperature difference between the core layer and the photosphere layer. It only occurs for a few minutes, and the presence of granule makes the surface of the photosphere uneven. Sunspots are dark spots on the photosphere, and it's dark due to the temperature, as this region is colder and there's less light. It exists for a few weeks, and drought occurs on the Earth when these sunspots are active. Solar cycle affects the Sun's activities in a period of 11 years. It occurs due to different number of fluxes based on time, and is also known as sunspot cycle. Solar flares are explosions of hot gases that occur on the chromosphere layer. It releases charged particles such as electrons, protons, and gamma rays. It usually occurs near the sunspot for a few minutes or hours, and extreme explosions can cause coronal mass ejections. Solar wind consists of energetic particles that move hundreds of kilometers per second and are emitted by the Sun to surround the Earth's magnetic field. Solar wind that's able to penetrate Earth's magnetic field will form an aurora. Sunspot and solar flare activities increase the strength of the solar wind. Solar prominence is expelled out from the photosphere to corona in ring form. It contains plasma, hydrogen, and helium gases and only occurs for a few days or months. Coronal mass ejection is an ejection of the Sun's plasma that consists of charged particles and heavy elements such as oxygen and iron. It travels through space with high speed, and it's able to reach Earth's atmosphere in 1/3 of a day. It's usually related to solar flares, but most of them are from sunspot areas. The Earth yields its own magnetic field that flows through from the north to south. This creates a shield-like field called the magnetosphere. The magnetic field will block the solar wind and cosmic rays from entering the Earth's atmosphere. The area facing the Sun will be hit by the solar wind that is up to 6 to 10 times the radius of the Earth. Meanwhile, the other side of the magnetosphere will elongate around 1,000 times the radius of the Earth. The magnetosphere protects Earth from the high-energy charged particles of the Sun brought by the solar wind. These high-energy charged particles move at high speed in space and hit everything in their path. The magnetosphere acts to dismiss and divert the high-energy charged particles to different directions. Space weather, driven primarily by the Sun's activity, plays a significant role in shaping our space environment and can have profound impacts on modern technology and infrastructure. Understanding and forecasting space weather is essential for mitigating its effects on satellites, communication systems, and power grids. As our reliance on technology grows, accurate predictions and preparedness become increasingly important to protect against potential disruptions caused by solar flares, coronal mass ejections, and other solar phenomena. Ongoing research and monitoring efforts are crucial for advancing our ability to anticipate and manage space weather, ensuring the resilience of our technological systems and the safety of our space-based assets.